So today we are still in 1.3, the final lesson, and today we are going to talk about non-rigid transformations. So up until now we have dealt with just rigid transformations. So when we're translating or we're shifting graphs just into a different position, or we're reflecting a graph from a different position, right? We're not actually changing the shape. It's like we're just sort of like the shape is rigid and we're just like picking it up and just setting it someplace else. So that's why those other functions are called rigid transformations. So this is our first one that will be a non-rigid transformation. So that means it's actually going to, now my graph retains a lot of its original properties. It's just that it does change its shape somewhat. Okay, so I'm using y or f of x equals x cubed today because this is a nice one that shows all the different ones. Now again, just like I showed with the reflection, that sometimes when I put a reflection in a certain place, when I have a graph that has a type of symmetry, then the transformation itself looks just like the other one. And so I've chosen x cubed because it kind of shows all of the different ones. Okay, so first of all, I just wanted to show you a thing that Desmos will do. So if I will define my f of x as x cubed, so this time I'm not using y equals, I'm using f of x, then it will actually do the transformations for me so this is something that you can practice with at home. So let's say I wanted to know if the shift f of x minus 2 was 2 to the right or 2 to the left. Well, I can just put that in there like this, right? And when I graph it, look, it just, as long as I've already defined f up above here is this red one, right? Then f of x minus 2, it just chooses your f function and then it does the transformation. So this would be the graph of, right, x minus 2 quantity cubed, right? That's what I do with the f of x minus 2. So I just wanted to kind of show you that. So I'm going to use that notation now when we're doing these, okay? So the first one that we're going to talk about are the vertical stretches, or we're going to call them, okay? Or actually, well, one is a stretch and one is what we call a shrink, okay? So, but we're first going to talk about vertical. And so my vertical transformations essentially come when my number is in front of the f of x. So maybe I have, like I have here, this 3 times f of x, which would translate to 3x cubed up here. And so 3 times f of x would actually give me this transformation, okay? And so essentially what this does is we call it a vertical stretch. You can kind of see, if you think of, basically, if you think of the red graph here, then what has actually happened is sort of like I've taken both ends and stretched it and made it a little bit tauter, and so it goes up a little bit faster and it comes down a little bit faster as well. So we call this a vertical stretch, okay? So whenever this number here, this number in front of f of x, is greater than 1, the absolute value of it is greater than 1, right? Because if it's a negative sign, then that just is talking about the reflection and it has nothing to do with the stretch itself. So when this number in front here, the absolute value of it, is bigger than 1, then I get this vertical stretch, okay? And so then if I think of this one here, let me take this one off. So when I look at this 1/3 f of x, and I've left the original graph of x cubed here, I get this picture here. And so when this number is less than 1, see the 1/3 here, it's between 0 and 1, not 0 itself, or else I don't have an actual, right, that's not included. But if I have a fraction that's between 0 and 1 here, then what happens is a vertical compression, or shrink is what we call it. I kind of think of it as, it's like something is pressing on the function and it's pressing it toward the x-axis, okay? So we call this a vertical shrink. Now, the opposite is true, right? So if I have a number that's bigger than 1, the absolute value of it, then I get a vertical stretch, and when it's less than 1, I get a vertical shrink. when I put it inside, so this is a different, right? So these, when they're inside, are not vertical. These are horizontal transformations, okay? But then they behave opposite of what the vertical ones do. So when I have f of 3x, this is considered a horizontal compression, okay, or a shrink. See how it basically just kind of squished my graph right in there. And so this one is considered a horizontal shrink. So if this multiplier in here on the inside is bigger than 1, then I get a horizontal shrink. Okay. When I end up with something, and again, when I put this in, the reason why is because f of 3x is if I put this in this x cubed, then f of 3x would be 3x quantity cubed, which is really, right, 27x cubed. So it's really going to pull my y values and really kind of shrink it horizontally, okay? So basically my graph is all in one little tight horizontal line. So now when I do the opposite here, let me take this off here. Helps if I press the right button. There we go. Okay, so I have f of 1/3. So now since this was a horizontal stretch, I'm going to assume that this will be a horizontal compression or horizontal shrink. And it is. So we kind of see that it's stretching my graph horizontally. It's taking up more space here. And so when this number in here on the inside function is smaller than 1, then I get a horizontal stretch, or yes. Okay, so I just want to put these all together then, because you can kind of see they're all different. So this is my red line is my original function. So the black line is my horizontal stretch. I've got a horizontal compression or shrink. This is my vertical stretch. You can see they're all a little bit different. And then this one here is my vertical shrink, okay? So it kind of looks like a little bit of a rainbow. It's kind of a pretty art project, right? So they're all a little bit different. But these, you notice, one thing to notice about all of these is while the shape has changed, right? It's a little bit more bent in some places, it's a little more stretched in other places, but I still retain my same basic shape, right? I'm still always got this general thing, right? I'm always starting in the bottom. I've got this little bit of a bend here, and then I come up here. Okay, so they all, even though my graph has changed, it's altered the original shape, it still retains most of its properties, okay? All right. And you can play with these, right? You know, go online and play with them on Desmos and see how they change all the shapes.